Hi everyone, the next problem we're going to be working on is number 11, which says a box with a square base has a surface area, which includes the top, of 3 meters squared. Express the volume of the box as a function of the width of the base. So we're looking for volume as a function of the width. So V of W, we want to find what that equals. So let's just think of what volume equals. Volume equals the area of a base times the height of whatever object we're looking at. So our base is a square, and it says that one width of the base is, or the width of the base is W. But since it's a square base, that means the length is also W. So if we're looking for the area of the base, we're looking at W squared. The height, though, we don't know what the height is, so we're just going to call it H. So we need to find what H is in terms of W. So we're not satisfied with this just being H right here. So I need to find what can H equal in terms of W. I can't do anything more with this equation at this moment, so I'm going to move away from it. I'm going to go back to what I do know. I do know from the problem that the surface area is 3 centimeters squared. So I'm just going to write SA for surface area is equal to 3. Well, what does surface area equal? Like, what's the equation for surface area? So all the areas of the surfaces. So if we're looking at these, we have this area right here, which is W times W. So that's W squared. And that's on the top as well as the bottom. So there's going to be 2 of those surfaces. So I'm going to write times 2 right here. Okay? Then we have 4 of these rectangles that have a base of W and a height of H. So there's 4 of those. So base of W, height of H, and there's 4 of those that we're adding on to this. Okay, so here's our equation. We know what that equation has to equal. It has to equal 3. So if I rewrite this now, I have something in which I can solve for H. So I can find what H equals, and then I can put it back into my volume equation. So I'm going to do that right now. I'm going to first factor out a W from each of these. So I have 3 equals, and a 2, I suppose. So we can factor out 2W. So take away 2W out of 2W squared, you're left with just W. Take out a 2 and a W from the 4WH, we'll have 2H. We can divide the 2W to the other side, so we have 3 divided by 2W is equal to W plus 2H. We can subtract the W now, so we have 3 over 2W minus W equals 2H. Well, how about we get this over one single fraction? So let's find a common denominator. This is really W over 1, so I'm going to have to multiply by 2W to the top and 2W to the bottom in order to get that to be common denominators. So it's going to be 3 over 2W still, minus, multiply the top by 2W, we're going to have 2W squared. On the bottom we just have 2W equals 2H. One fraction would be 3 minus 2W squared over 2W equals 2H still. We can divide by 2 to get that over to the other side, or we can think about it as we're multiplying by 1/2 to each side. That will also get rid of that 2 for us. So when we do that, we're going to be left with 3 minus 2W squared over 4W. Okay. All right. Now with that all there, we can substitute it back into our equation. So over here, H really equals 3 minus 2W squared. And that is all over 4W. But notice we have a W in the numerator that's going to be multiplied through, and we have a W in the denominator. So I can reduce 1 on the top with 1 on the bottom. So I'm going to be left with W times 3 minus 2W squared all over 4. And then lastly, distribute this w all the way through the numerator. So 3w minus 2w cubed now over 4. So all of these were volume, and finally we have volume in terms of w, which is what we wanted in the end. That is our answer.